All right, all right, all right. Good evening to all the grade 12 students. Welcome back, welcome back. This is your money man back again with day 12 series. What do we say? Thumbnail says electrochemistry in 100 questions. Yes, we have started the series yesterday, students. So today we are going to go to the next questions, next set of questions rather. I'm going to cover complete electrochemistry in 100 questions. This 100 questions is a crucial point. Every question is unique and every question is important. Stay connected. Welcome to all the new students and welcome to all the old students who are there with me. All the new students who are watching me for the first time, Namaskaram, hello, Vanakkam, Shastri Akal, Adab, but say, Chanagidra, Baunara, everybody welcome. All the new students, don't worry, all the best. All the old students, you have tuned to the channel. Thank you so much for that. Let's start. So, as I said, today, or rather, this particular series is going to cover NCRT line by line. That's of your electrochemistry. This complete 100 questions, whatever I'm going to do, those 100 questions are going to cover 1 mark, marks, 3 marks, and 5 marks. Done. So, whatever numericals are there, all the numericals I'm going to cover in one shot. Everything is going to cover like day by day in and day out. Like rather, as you watch, all the numericals will be covered. Don't waste time. Let's start. Time is precious. So, as I said, I've completed this chapter, students, already in this 30 days challenge. First chapter, which, or rather, I think, yeah, solutions is what I did. This I've covered completely, 100%. Then I went to haloalkanes and haloarenes, everything. Now I'm going to do electrochemistry. Then follows your inorganic chemistry. Don't worry about that. So by your board examinations, all will be covered, everything. But only important thing, you're going to follow me day by day. And please share the video. Chalo. The next question, which I'm going to solve today after yesterday's question, this is a continuation of yesterday's video. So, continuation of the yesterday's video. So, please watch the day 11 video, so that it is easy. Chalo. So, here I mentioned, right, in the starting, what did I say? I said day 12. So, please watch day 11 video. Let us read the question. Write the Nernst equation and find EMF of the following cells at 298 Kelvin. They have given me magnesium cell with the concentration and copper cell with the concentration. I have to calculate Nernst equation. First of all, what is the Nernst equation formula, students? Yes, you very well know. We are going to calculate, or shall we write what is given to us first? Okay. So first of all, what is visible to me in front of me? I'll write that. For magnesium cell, whatever magnesium getting converted to Mg plus 2, right? Mg plus 2. So a magnesium getting oxidized to Mg plus 2. How much is it? What is its concentration? 0.01 molar. 1 molar. How much is copper? C plus 2 reduced copper. The concentration is 0.000 m. So this is for you. Now what should I find out? I have to find out E cell, correct? Na? They asked me to find out the EMF of the cell. E cell is what I have to find. Cell is how much? That is what I have to find. All right. Now let me write the Nernst equation. First of all, E naught cell is equal to, first I'll calculate E naught cell. What is E naught cell formula? Right? It is the cathode minus anode. What is there in the cathode part, which is getting reduced? So this cathode. What is cathode? Not copper plus 2 by copper. Yes, not magnesium plus 2 by magnesium. We all write in terms of your reduction potentials. Yes. How much is copper? Normally the electrode potential value is 0.34 for copper. This is given also, and this is known value. Right. Minus for magnesium is 2.37. Did they give me here? Not given. Now, how do I remember? They'll be giving it to you. But generally also zinc, copper, magnesium. Try to remember. It's C because those values are smaller values. Okay. For magnesium, the electrode potential, because I have converted this both into reduction potentials. So this is 2.7, that is minus. So when I subtract both of them, I'll be getting an answer. So how much will I get? 0.34 into minus plus. So I'll be getting into 2.71 volts. This is your E naught cell value. Now I'm going to write the Nernst equation because I have to calculate cell, right? Nernst equation. What is Nernst equation? Cell is equal to not cell minus 0.059 divided by n, right? N. So N, how many electrons are getting transferred from magnesium to copper? 2 electrons. What is the log value? Log oxidized by reduced. It is oxidized magnesium plus. It is reduced. It is copper, right? It is copper plus. This is done. Magnesium and copper. They're done, students. Done. So now, careful. Let me substitute the values. E cell I have to calculate. Okay. How much did I get? E naught cell. E naught cell I got as 2.71. This 2.059 divided by 2. Log. How much is a magnesium value given to me? Magnesium value given to me is 0.001. This 0.001. Let me write 0.001 divided by copper value. How much is given me? 0.001. Right? Check, go back. Did I write 1? I forgot to write 1. So, okay. This is the value. This is the value. Now oxidized. Gradually, how to do this? As I said, careful. I did one video for how to find log without log tables. Please watch that. So log a by b equal to log a minus log b. Convert everything to base 10. Convert everything to base 10. So what did I do? I have solved first this part. Then I solved this part. 0.059 by 2. So I'm getting 2.71 is 0.025. So I've taken out everything, cancelled the 0.01 log a minus log b, right? So I'm converting everything to base 10 or log 10. What is log 10 value? Equal to 1. So you subtract these 2.71 minus 0.25 because log 10 is equal to 1. I be getting an answer of either an answer of 2.605 volts. So this is the fact. Right, again I'm saying, students, please watch that video, how to calculate log without a log table. Without log table, very important video. Please watch this video. Okay, done. It's done. This question is done. Gradually I'm going now. One more question. Define the term resistivity and give its SI unit. Question: what are the factors on which conductivity of electrolyte depends? Okay, molar conductivity 0.21 molar CH3COH solution is 4.6 meter square. What is the conductivity? I have to calculate that. Let's start point one after the other. First, define the term resistivity. So how many pages do I have? I have this page. I have more pages. I have 2 pages. I'll use both the things. First question. First of all, resistivity. Okay, let us write resist of which one? Of a substance, rather. Resistivity of a substance. So as the name suggests, resistivity is nothing but resistance. Okay? Resistivity of a substance in its resistance, rather. When it means I'm talking about resistance. So in its resistance, how, ma'am, what is this? In its resistance. So what is this? When do I call this as resistivity? When careful students understand, when it is 1 meter long. So it is a resistance of a substance. It is 1 meter 1 meter long, and its area of cross section, its area of cross section 1 meter. Then it is called, again, resistivity of a substance is its resistance. When do we calculate this resistance? When it is of 1 meter long, yellow wire, its area of cross section is 1 meter square. What is a unit of resistivity? It a unit of resistivity as ohm meter. Ohm meter unit for resistance. Okay, first question is done. Let's go to the next question. What are the factors on which conductivity of an electrolyte depends? What factors does conduction be? So conductivity, first of all, conductivity means from where did we get basically the concept of conductance? That is what? Okay, let us see. Conductivity, electrolyte. Okay. That is resistivity, this is conductivity. Conductivity of an electrolyte. So basically, whenever something is conducting electricity, depends upon conductive electrolyte. depends on first thing. Let us write what it depends on. First, depends upon nature of electrolyte. Electrolyte. Okay, this one first thing. Nature of electrolyte. What electrolyte you are taking? Whether it is a strong electrolyte, whether it is weak electrolyte. Next, it depends upon size of ions. Size of ions produced. This is also correct. Okay. Third one depends upon the nature of solvent what you are taking. First, the solvent also plays a important factor in determining or dissociating the ions. Next important thing, solvent is there and its viscosity, how thick it is, whether it is viscous, viscosity, whether it is dilute, whether it can conduct. Last one, concentration, not last one rather, concentration of electrolyte, and last but not the least, temperature. This is very, very important. But it's from, so you learn this conductivity, you learn this. Do I have one more page? Okay, see part I'll write. Learn that conductivity factors. This you can, they will ask you for 1 mark also. See, I'm continuing here. What is the next one? Asked me the molar conductivity of zero point 0.1 molar acetic acid in 4.6 centimeter square mole inverse. What is the conductivity resistivity? C part. What did they give me? They asked me, first of all, what did they ask me? They asked me conductivity and resistance. Formula lambda m K in 1000 by C. Correct? Yes. Okay. So now lambda m is the first of all, what do they say here in this when I see the molar conductivity of zero point 0.1 molar. This is a weak acid, right? Solution is 4.6. Okay. So isn't it this value greater than K? Yes. So can I write this as K, can I write the same, this one as lambda m into C by 1000, right? What did I do? I took out K, I cross multiplied this. If this is confusing you, it's simple, just cross multiplication is what I did. Right? Now go back. What is lambda m value given to me? This 4.6 centimeter square mole. What is concentration? 0.1. Yeah, divided by 1000. I can apply, right? Lambda m given to me is 4.6. 0.1 divided by 1000. Okay. So conductivity, I took it outside. Took it outside to calculate here. K is equal to, when I multiply, I get a value of 0. Which I did earlier, 46. So normally I work out the sums for you so that it is easy for me to give the answer directly. And by set. Yeah. Done. Conductivity. What is resistivity? Conductivity. Conductivity. This is resistivity. The formula is rho. Correct. What is rho? It is inverse of conductivity. So it is equal to 1.0000. This divide it is 2.72174 ohm centimeter. Ohm. So this is conductivity. What is done? Perfect. Go gradually. Don't worry. Gradually you go and ask doubts in the comment section. Next question. State the factors. State the factors that affect the value of electrode potential. Okay. So electrode potential values which will affect electrode potential value, right? Electrode potential values. You have seen RP and SOP. First of all, it depends upon most important thing, right? Which one of electrolyte? Whatever electrolyte, whether you're taking strong or weak, it depends upon the concentration of electrolyte. And it depends upon temperature. Temperature, as we said. Third, third. Tell me what is the third one? Can you guess me? Tell me in the comment section. Let's see. They asked me. Next, they asked me this question one. They asked me, I have a next page so that I can write there. Yes, yes. They asked me write Nernst equation for aluminium zinc sulfate cell. Equation for aluminium zinc sulfate cell. That's it. They gave nothing else. So how should you write? For aluminium zinc sulfate, first you should know which is anodic reaction. Now you see here, aluminium zinc. Alumi- Aluminium metal donates 3 electrons, correct? Na? So the cell reaction will be called cell reaction. First of all, we'll write cell reaction. Aluminium is getting converted to aluminium. In between both of them, there is a salt bridge. Then zinc plus 2 by, correct? Na? Now in this anodic reaction, because at anode, what will happen? Oxidation will happen. What? Loss of electron, correct? Electrons will be lost. Which one? How many will aluminium give? It will give 3 electrons plus 3 electrons. At cathodic reaction, what is going to happen? At cathode, basically oxidation is done. Here, reduction. What is this reduction? Correct? Now take it. Zinc will take up 2 electrons. Zinc plus 2 will take up only 2 electrons. It was only 2. Yes. Now, are you finding any difference in electrons? Yes. Here there are 3. Here there are 2. What will you do to balance this? You're going to multiply this equation with 2. And you're going to multiply this equation one with 2, this one with 3. So now you cancel see the electrons. P2s are 6 electrons, the 6 electrons. The electrons cancelled here. The electrons get cancelled on. It is left here. Aluminium. Now, then here below this is Zn. But one thing you're multiplying electrons, the whole you're multiplying with aluminium also. This 2. Here you're multiplying with 3 means here also zinc is 3. Gives me here 2 aluminiums you're multiplying Al plus is 3. And 3. Now, he asked me to write what Nernst equation. To go to that. Nernst equation, what is electrons? Cell is 0.95. How many electrons? The sides electrons. Right? Log oxidized by reduced. What is oxidized here? Aluminum. How much was the charge? Means electrons. 3 twos are 6 divided by zinc. Zinc. How much was the charge? 2. Electrons. It is. So this is. They asked me to write Nernst equation. I've done it in the Nernst equation. So you should start from cell reaction. Then you should go gradually anodic reaction, cathodic reaction, complete cell and Nernst. Done? Perfect. Chalo. Hope you're understanding the questions. Let us go to the next question. What is the effect of temperature on molar conductivity? Okay. Right. Molar conductivity definition. Let's recollect. Correct? Now, simple. I have to write this in one word. Now, molar, don't expand, don't write the definition. Molar conductivity increases of which one students basically molar conductivity of an electron. And molar conductivity of an electrolyte increases with with temperature increase with temperature. So can I write as molar conductivity and temperature are directly related, right? Because the number of ions per mole will increase. Next question, right? Why is it not possible to measure single electrode potential? Single electrode. Okay. What is this concept? Let us see. First of all, in a particular electrochemical cell run, you have an anodic compartment and a cathodic compartment. Yes. They're asking why I can't calculate single electrode, only one anode, either anode or cathode. What happens in half cell? Let us see. I'll start with because why they're asking? I'll start with because the half cell, whatever you're taking, half cell reaction, whatever you're taking, containing single electrode cannot exist independently. I'll tell you why. Cannot. First, we will write. You'll justify the answer. Cannot exist dependent. Dependent. So why? As independently as charge cannot flow on its own because it has to go oxidation happen then reduction. From anode to cathode, the electrons flow, then only your circuit can complete. Here you're seeing single electron. Then I'll write as charge. I'll underline this. Cannot flow on its own a single electrode. Charge cannot flow. Electrode is what? Right? Question. Let us go to the next question. What is the effect of temperature? Can I check whether it is getting recorded or not, students? One, can I check? Can I see? Yes, it is recording. So I'll go to the max again. Right. Okay. Recording. Let's go. What is the effect of temperature on the electrical conductance of a metal? Okay, just now I said, na, whenever you see conductance, that directly. Electrical in molar conductivity is directly related to temperature. So remember, electrical conductance inversely related to temperature. That means if electrical conductance increases, or rather, we'll start as the temperature increases, electrical conductance decreases. Because the number of ions they dissipate, they dissociate far and far. Because of which the electrical conductance, right, students, indirectly relate. Next question. What is the effect of temperature on electric? Is it the same question? Temperature of electrical conductance of a metal? No, no, no. This is different. This electrical conductance of metal they gave. Here they asked, what is the effect of temperature on electrical conductance of electrolyte? Simple. Electrolyte. Yes. Electrolyte means the electrolyte sulfuric acid if I take that provides the electricity automatically starts picking up. But if it is a strong electrolyte, you have to be careful. Observe the careful. Electrical conductance directly related to temperature. Which one of electrolyte? Different. Different. This is of electrolyte. Of electrical conductance of metal. Because the sea of electrons which are there. Yes, that is a constant. This is of metal and this is of electrolyte. That means as the temperature increases, electrical conductance increases. Okay, let us see the next question. What is the relationship between conductance and conductivity? First of all, remember conductance. Maximum students get simple concept only, you get confused. Conductance symbol, conductivity symbol. So this is C. This is conductivity. So both formulas are lambda C by M is equal to simple. Conductance and conductivity. First related. Next question. Reduction potentials of four metals A, B minus 0.66 plus 0.34 plus 0.82 minus 0.76. What is the order of the reducing? All these are reduction potentials. Potentials means which one you will see minus sign. Correct? Na? Reduction potentials means the minus sign. So four metals are there. Order wise, is having which what is the order of the reducing? First thing. First is A. How much is A? Let us write first. A is how much, students? Minus 1.6. Is it reduction potential? So I am writing that reduction potential. Is C plus 80. What is D? 2.76. Start answer question. Do I have space? Page no. I'll write. First is A. Minus is over. That next minus is that B. 0.34. Because you're proceeding from negative towards the positive. Highest. So this is the C. Order for reduction. Carefully you observe whether they begin oxidation. Done. Write the overall reaction take rusting equation. Rusting. First of all, rusting happens in presence of happens in presence of what is required? you require first of all iron metal, na? The one which rusts. The iron metal requires. Okay, on this only rusting happens. Then, then, then whatever moisture is there, the surface moisture, okay, certain acids also are there in the atmosphere. Together, I'm writing an ionic reaction. Iron combines with oxygen and your H plus ion acids which are there. It forms Fe plus 2 ion, iron oxide plus water. So, if I balance this oxygen, the hydrogens are 4. Oxygen is 1. So, iron here, Fe plus 2. Okay, Fe plus so 2 iron atoms will balance. 2 twos are 4 protons. See this. So, 4 protons, 2 into 2, 4 electrons. The ionic reaction. Take this reaction for exam. Examiner will give you full marks. Write the overall reaction rustings. Repeated question, students. Sorry for the inconvenience. Repeated. So just ignore the question. I've already done earlier. Next question. What is the reaction taking place in the cell between aluminium and aluminium plus 3? They are asking me three reactions. Question. Only reaction. First, which is getting oxidized? Aluminium. Right? Aluminium. Which is getting reduced? Copper. Aluminium gets converted to what? Converts L plus 3. Correct? Na? Copper is getting converted to, only tell me. Aluminium, if I write the reaction, let me write the reaction. You will only understand that. Aluminium is forming Al plus 3. Just reaction wise. Al plus 3. Plus how many electrons? Electrons. Copper plus 2. Plus 2 electrons gives me copper. Is it correct? Correct. See the electrons. So I'm going to multiply this with this one. I'm going to multiply with an overall reaction. Electrons will get cancelled. Electrons now multiply. This will become 2L. Correct na? This will become 3Cu plus 2. This will become 2Al plus 3. This will become 3. Correct na? 3C. So write the above reaction. 2Al plus 3. Copper is 3. Aluminium is 2. Copper is again 3. You are going to write in the exam only this. It is a 1 mark question. Okay? Question. Why sodium cannot be by electrolysis of aqueous NA? Why sodium cannot be this product of electrolysis? So simple concepts. See, sodium when I see in the electrochemical see is what is the reduction potential value. We normally according to IUPAC we take the reduction potential. Sodium as due to low reduction potential. Reduction potential. With this low reduction potential, Na plus not reduced. Where is the reduction happening? Are not reduced. Reduced at cathode. So in that reaction, what is instead of that, what which is getting reduced? Instead H plus are reduced. H plus are reduced. And when H plus are reduced, they get converted. That's the concept. Sodium cannot be electrolysis. Question. What is the use of platinum foil electrode? Thin platinum foil hydrogen. Yes, what is the use of that? This is conductivity. Does platinum conduct electricity? Yes. It is used for the inflow and outflow electron. Helps in the passage of electrons. So platinum foil, whatever is there, platinum foil will help inflow to, that's all. You don't write anything else. Reactivity, less reactive, this inert, simple passage of electrons. And next question. So this is repeated, done, already done. So next question. Why lambda naught for acetic acid be determined experimentally? Acetic acid, when I see I see acetic acid only, I can directly see the concept. Acetic acid. This is acetic acid. It is a weak electrolyte. Correct? Na? From here only I can get it is a weak, right? This answer this. This is molar conductivity. Molar conductivity of weak electrolyte. Molar conductivity of electrolyte. Does it increase? Yes. Keeps with dilution. Correct? Na? Keeps increasing with dilution. Not strong electron. Only interatomic forces will change. Right? Increases with dilution. And because of this, it it doesn't become constant even at a very large dilution. Keep increasing and does not become constant at very large dilution. That's why it keeps increasing and increasing. Because of this, I can't the lambda conductivity value experimentally. Keeps on dissociating. Next question. What is the necessary of salt bridge in galvanic cell? Oh, simple question. Anybody can answer this. So, in a galvanic cell, your salt bridge is there. Only one keyword will be there. To complete salt bridges, you complete this inner circuit. So, once it completes inner circuit, what is going to happen inside the cell? It because of this, it maintains electrical neutrality. The compound maintains electrical neutrality between what electrolytic solutions in electrolytic solutions of half cell. Electrolytic solution. That's simple. Simple. Next question. What is the why does the conductivity of a solution from dilution? First of all, conductivity and conductance are inversely related, we said. Correct? On this conductivity of a solution, what does it depend? Yes, conductivity. Conductivity depends upon activity depends upon number of ions. Depends number of ions per unit of ions per unit. This is okay. Per unit volume is what it's going to count. When you're diluting this, dilution, which will increase number of ions will increase dilution. Number of ions per unit volume increases. Correct? Na? So when it increases, no, 1 minute. So on dilution, more and more will dissipate. It will distribute itself. More and more will increase. Means the per unit volume when you check, you'll not find very closely dissipating. It is associating. Number of per unit volume decrease. You can't count per unit volume when you take. You can't count it. Correct. Because of this, hence conductivity decrease. Correct. Because all have distributed at one particular unit volume where you count it. Correct. Ah, next question. Out of zinc and tin, which protects iron better even after cracks? Why? So, which will oxidize faster? Which is more reactive? Zinc and tin. First of all, okay, let us take this. Zinc is better because zinc, the protection is, see, when I compare zinc metal and when I compare tin metal, which will corrode faster? Will corrode faster? This will corrode. Take the oxygen and it itself gets oxidized. But tin is less reactive than iron. We want iron to be protected. Na? Iron to be protected. Whatever zinc layer you're covering, zinc layer, this layer only to be more reactive so that it will only gets oxidized. In this case, what happened? In case tin is less reactive than iron. So what will happen even if you're covering tin on the surface, less reactive, this will get corroded with oxygen. That's why zinc is more reactive than tin. Because of this, what will happen? Because of this, I can use only zinc. Only is more reactive than tin. Hence, zinc is used. Hence, zinc is to protect. So, next question. The conductivity of 0.02 molar solution ACl is 2.6 is to Coulomb centimeter inverse. What is its molar conductivity? Is it right? Do I have a page? Yes, I have a page. What is given to me, alright? Then I'll solve. Given. What is K value given? Conductivity zero point 0.6 to 10 raised per inverse. This the conductivity given to me is 2 R. Okay. Then what is the formula? They asked me to find molar conductivity. So A into 1000 divided by and the value becomes simple one like this in the exam. Substituting the values, the given formula, which is that given to you 6 10 days 1000 divided by point. Can I convert this to 2.6 in 10 days per 26 26 and no, the 1000 is there. No, can I write it as 1000 divided by 1000? I can write it as 100. I can write this as 100. I can write this as 100.02. Correct? No? It's easy for me. Right? I can cancel. This becomes 26 in 10 days per 2. Perfect. I got an answer. Check the calculations. 13 into 10 raised per 2. Siemens centimeter. The answer. Check student. Lambda m value. I got that. Chal. Question. Given the product of electrolysis, given the product of electrolysis of an aqueous solution of AgNO3, given give the product of electrolysis aqueous solution AgNO3. Please remember students, handwritten notes. My handwritten notes I did given how to calculate product of electrolysis. Product of electrolysis concept I very nicely wrote and given. Please study that. This is an important question. So silver nitrate. Will write anode. Do I have a page? I have a page. Can I write next page? Chalo, next page. At anode. Anode. Silver it is plus at cathode we think that silver will accept one electron. Silver at silver nitrate, that is an electrolyte which okay, that's it. Just ask you to write the reaction. Next, this is one more question. The resistance of a conductivity cell, okay, resistance of a conductivity cell containing 0.001 molar solution ACl at 298 Kelvin is 1500 ohms. Okay, what is cell constant? Cell constant. Cell constant of so much. So the cell constant formula is K into correct na? Done. The question. Which is K value given? Will we write given because I have a place next? I'll write here. Given values. Given values. There is a chal. Given values are what students? Given the value 1 4. This 1500, that is R value. Okay, 1500 ohm. Okay, okay. Try both of them. Cell constant, cell constant R. Okay, 0.146. This 10 10 raised to the minus 15. Did they give me Siemen centimeter? Correct? Na? Okay. 10 centimeter in ohms. When I multiply, get it as 2.9 centimeter in ohms. Correct? Na? Ohm, and that is K given in ohm. I have taken that and Siemens centimeter. Question. Determine the values of equilibrium constant of Kc and delta G naught for reactions. Calculate equilibrium constant delta G naught. Calculate. So let us write the formulas. Delta G F E naught cell. What is given to us? Given much is N 2 electrons here, Ni plus 2 electrons, and this 2 electrons. What is E naught cell value? Cell here it is given and 0.5 volts. What is Faraday given to me? For Faraday value 96,500. Now apply delta G naught equal to minus NF minus NF E naught cell. N is this one F Faraday 96,500 and 5 into 1,500. Delta G naught to 2 into, if I multiply all together, I got 10.650 what I got for delta G. But they asked me to get Kc also, right? Kc also. Next formula, do I have place? Yes, I have. Second thing, delta G naught RT ln. I did one short video. So this short videos will help you more clearly. Okay. So Kc. So they asked me Kc. All right, students. This Kc value I calculate. Can you calculate and tell me the answer? Calculate and tell me the answer. Me, what is the value? So R value, temperature value is given to me. They have given determine the equilibrium values. Okay, for the following reactions. Okay, temperature value, standard temperature, ln Kc. Correct. Can you just G naught value I already got. I already got G naught. R value, value, and take it out. And can you calculate and mention this in the comment section? Can you try and tell me whoever will give me the correct answer? Correct answer. Correct answer. That's two and will be pinned. And will be pinned. So I'll meet you again tomorrow, students. Before saying thank you to all students, said tomorrow, but remember every day you need to study chemistry. Poison, slow poison. Okay, so practice every day. Okay, I request all of you please like the video, share the video. Most important, send me your cute comments. Waiting for that. Bye. Take care. Thank you so much. Signing off. Bye and stay happy all.